Okay, so we've had our overview of the Anycubic, and we're now going to prepare a file using Cura. I wanted to show you a little more clarification on what an STL is and how one might go about doing that. So I've opened SolidWorks because in converting a SolidWorks part to an STL, you actually get to visually see what exactly is taking place, the triangulation. I also wanted to show you how to navigate into the student work folder that's on the common drive that you at home can virtually access through the VM software, the VMware that we're making available to you. The link should be available in your Canvas, or if you do have questions or would like to receive it and don't have access, please just let me know. So I'm going to do a file open, and I'm going to access on this PC, it's this CAD Lab J drive, and in there is the student work. And I just dropped this SolidWorks part into here. And this was a part we created for our cohorts over in chemistry. They needed essentially a slight weight that was a precise weight. And so a member, actually a few members of our Maker Club created this for them. So here is our feature tree. Here it is in SolidWorks. Now we want to get this into that standard triangulation language or standard tessellation language format. So I'm going to, in this particular case in SolidWorks, it's a file save as. In a number of softwares, including AutoCAD, you're actually exporting it into that file format. So if we do a save as and save as type, it's about halfway down the list here, it's this STL. So if we were to save it as that, so do you see that essentially what has taken place here is literally the geometry has been triangulated. And so it's almost a constellation of points that the system is going to be providing to the, ultimately to the printer in the form of G code. So it's just telling the printer X, Y, and Z go from there to there to there. And in this particular case, there are 2,680 triangles. And here is the file size in bytes. And we're working out of a binary file format. So I'm going to say yes to that. It saved it into that same area. So I'm going to go ahead and close SolidWorks. And now I opened Cura already. So here is our printer software. This is the icon, this Ultimaker Cura. As I mentioned in the overview of the Anycubic printer, because it is open source, you could use any number of slicer softwares, which is definitely a huge benefit of something as affordable and powerful as this Anycubic. Most of our printers do require their proprietary software in order to load an STL into them. So I'm going to go ahead and open the file. And again, it's in that student work. So here it is. And here is our part. And it's quite small. As you see, it's actually a very, very small part. We could manipulate it, adjust it. Something else that's nice is, as you see, this software, let me get this out of our way. This software has been created, or excuse me, this software has added the particular printer. We have that option. So it has the print envelope, the knowledge there. And we also could create some settings for it regarding the heated bed, the extruder nozzle head temperature, and whatnot. I'll also point out how similar this looks to the Dremel software if you have watched those Dremel tutorials, the Digilab software for Dremel. Very, very similar except for the print bed. In fact, there is the recommended and the custom settings. And as you see, these are almost identical. So I dare say that Dremel just took the tried and true Cura format and really built their platform off of it. If we were to go with the recommended, we could simply choose a layer height that most likely we would use just the default. Infill, so on a part like this, it's so small, really the only infill you may have is probably through this cylinder. You may or may not want to fill that because this needed to be a precise weight. That is one way we could play with this part to get it to the exact weight. If this were under a great deal of tension or torque, we may need to turn up the infill. We could also enable the gradual so that it will gradually get more infill one way or the other. And also we could generate support and or build plate adhesion. So you see this part is such that here's that red showing that this is unsupported. These overhangs are such that they would require support. Now we could play with the orientation of this model. So if we select it, again, the same icons even that we saw in Dremel, we could rotate this. So let's say we wanted to try it in that version. If you notice, there's still too much material that would be exposed if we were to not generate support. So I dare say no matter how we do this, even if we, let's say, leaned it on its side with a portion of it touching, you notice that any way we do this, there's going to be a need for support. Now, if we did orient it this way, there would require probably, well, just down here, there are some fragile pieces down here. And so keeping in mind that there is only one extruder head and our support and our build material is coming out of that, these somewhat fragile pieces might be in jeopardy of being snapped off as we remove the supports. So that's a consideration. It is nice that we could build this upper part without any support, but because the Z layer is being built with relatively small amounts of surface area, this piece could be fragile and snap rather easily. So again, considerations need to be taken as to how you might want to orient this. I mean, theoretically, I suppose you could even do it like this, but then you notice you've got a great deal of support that's required here, but these are rather flat areas. So it might be easier to remove them and not jeopardize your faces and your assembly portions or your feature portions up here. So these are all kind of considerations that you might want to jump into the software and test. Lastly, so I think for the sake of this video, we'll just leave it in this form, okay? And we are obviously going to generate the support because it's required. Also, because there is such little surface area against the build plate, in this particular case, we definitely would also want to create build plate adhesion. So that is essentially a raft like we saw in the dimension, something that is printed, essentially a base, creating more surface area against the print bed to hold the part. So that's just using the straightforward recommended. And if we went with those settings, this would take approximately 25 minutes. And this particular form of Cura actually doesn't generate a gram. Keeping in mind the Anycubic is $1 minimum cost plus 10 cents per gram. We actually would need to run this analysis in the Dremel software to get the precise gram cost. So that's one slight trade-off. The newer versions of Cura do a better job of calculating. Our hunch is because it is linked up to this Anycubic, it's just not calculating correctly. So let's jump into the custom. And here we just have that much more control over our settings. So for those who are real enthusiasts or who know their machine really well or who might be working with a particular type of filament that they know have particular settings, then this might be the best option. Again, normal is the default, the 0.2 millimeter, that's what we're gonna go with. Our quality, the layer height is usually a 0.2 or a 0.3. We're gonna keep it at the 0.2. The wall thickness, that's the that thickness, the minimum thickness of the walls at all points, and that's the 1.2 millimeters. We could thicken that if we wanted this to be a more robust piece. Infill, by percentage, we could even get down to 0.5%, etc., and do gradual infills. The material, so this is where if we happen to know that, let's say we have a nylon blend, we might need to turn up the printing temperature. Pure PLA, this 200 degrees Celsius and the 60-degree print bed seems to be a really good starting point. We can tweak these accordingly, and there is some trial and error that often goes into it. Another piece that we might want to work with is the flow rate of our material as it comes out of the extruder head. I'm going to leave these as the default because these seem to be running well with the Prusa Galaxy Black, the filament that we currently have in there. We could change the speed. And so these are some very, very nuanced adjustments that could be made as we become familiar with the printer. Again, for the sake of this tutorial, we're just going to leave them as is. But if you were to spend maybe a week or two doing some really voluminous printing, these might be a consideration to play with. We could, the print will cool down obviously once it stops, and we've checked that to ensure that it's easier to remove off the print bed. Support, yes, we have generated it and we want it everywhere. Now there are some options there, only touching the build plate. And so in this case, that actually is probably the same thing as everywhere. Not always is that going to be the case. So I'm going to just stick with everywhere. And then build plate, yes. So the brim is basically the same thing as a raft. So it's where the shadow is seen, that would essentially be a raft. It would be built to give it a little more, maybe a little even larger diameter of a circle to create that surface area. We could also, I guess that's, so the brim is similar to the raft. The brim is not as significant as the raft. And then the skirt actually is just around the exterior. And if anything, that's almost more just to get the extruder nozzle printing so that we can make sure that it's not jammed or clogged, and so that it's providing a nice liquid flow out of it. So now that we've done those pieces of analysis and we've chosen between custom and recommended, we can save it. Again, we are using a flash drive with the SD card put in it. So we're going to save it to that removable drive. And now we can take that out. I'm going to eject it. And this is the USB. This is the SD card. We're going to stick that into the printer and the print will begin. So that, in a quick overview, is the Anycubic i3 Mega.